All right, so we're going to start taking a look at these first few examples, and we're going to use the functions that they give us to identify the transformations that have happened. So in example 1, it says, given that f of x equals x squared, so that's that parent function, what effects do the transformations in function g have? So anything that's not an x squared is a transformation. And so if I look here, I've got this 1/2, and I've got this plus 4. This f of x right here, remember, that's just the x squared, all right? So this is the same thing as saying 1/2 x squared plus 4. And so when I look at this, multiplying by 1/2 is the first thing I have. I am multiplying my function by a value. And so if we look at our rules, when I am multiplying the function by a value outside, I've got to look at what the value is. So we had a 1/2. So that's going to be in between 0 and 1, which means this is a vertical compression or a shrink. All right, the verbiage changes from year to year on which one. Just remember they both mean the same. I'm just going to say vertical shrink. And remember, this causes it to widen. All right, and then this change over here, we're adding 4 outside of the parentheses. So if I look, outside means I'm vertical. And when I add outside the parentheses, we said that that's going to cause us to shift up. So this is our our function. We're adding something to it. So that's going to cause a shift up. And then so it's actually going to shift up by 4. All right. And so what we can do is we can go to our Desmos. If you can hear my chickens in the background, I don't know why they're being so crazy. We can actually type this in and compare and make sure that we filled out the right thing. And so what I'm going to do is I'm going to type in that first function that I had, the f of x. Let's see, f, parentheses, x, and then equals x squared. All right, so there's that original, that parent function. And then for line 2, I'm going to type in the new function they gave us, which was g of x equals, and then we had 1/2, and then I need another f of x, so f parentheses x, and then it said plus 4. All right. And so the red line is our parent function. The blue is that new one, that function g. And so you can tell my blue line is wider than the red line, okay? It kind of moves outside of it. We can also see from the vertex, it's not moving at the same rate as it was before. So in the parent function, which you can see here, for my vertex, I can start at the vertex and I can go up 1 over 1 and be on my graph, all right? You can see on the blue one, it doesn't work out that way, all right? Well, it's not enough to get us back on our blue line. So that shows you it's gotten wider. And then you can also see your vertex is 4 units up from the original parent function. And so that's a way to compare these and see if you've gotten the right transformations. All right, looking at example 2, how has function g been transformed from the quadratic parent function? So this time they don't have the f of x in here, but they did put that squared. All right, so they've just written this in regular quadratic notation. We're not having to look back at the parent function. But remember, the parent function is just x squared. So we've got several transformations happening. We've got this negative outside the parentheses. We've got a plus 1 inside. And we've got a minus 6 outside. So that negative out front, that is our vertical transformation. And so when I have a negative out front, it reflects us across the x-axis. It's going to flip us over. And so for that one, we're going to say reflects across x-axis. And they might say reflects over the x-axis or flips over the x-axis. Either way, it's a vertical reflection. All right. So that is because we have a negative multiplying our parent function. Next, we've got that +1 on the inside. And so with that +1 on the inside, since it's on the inside, that means it's a horizontal transformation. So if I look at my rules, when I add on the inside, we said that we need to shift to the left. All right. And so I'm going to go back over here and I'm going to say that this one, since we're adding on the inside, that's going to shift left. And so that means that that value is actually going to be at -1 when I have shifted to the left. So starting from 0 for the parent function, now I've moved over to -1. So that's that horizontal transformation because it was inside the parentheses. And then we've already looked at vertical transformation in the previous one. When we added 4, we shifted up. This time we're subtracting 6, so this is going to shift us down. Okay, so we are subtracting a value. So this is going to shift down. And it's actually going to shift us down to -6, going from 0. All right, so there's our 3 transformations. Once again, I can check it here. I'm going to clear this out. I can leave that parent function in there. It's not going to hurt anything. But now I've got negative parentheses x plus 1 squared. Whoop, hold up. This doesn't always register my pencil. X plus 1 squared minus 6. All right. And so you can look. We can see that blue one is flipped over. It's opening down now. And if I go from the red vertex to the blue vertex, I have to go left by 1 and down by 6 to get to it. All right. So example 3 says, graph and describe the transformation of the quadratic parent function f shown below. All right, and so they've given us this function. All right, I still got that f of x equals x squared in here. I'm going to leave that alone. And now I'm going to type in this new one that they give me. So my new one, it says f of x f of x plus 4 minus 5. And so I just typed in this function right here. I'm leaving that f of x equals x squared as my first line because I have an f in this new function, so I need something for it to reference to. And it lets me see what this looks like on the graph. So looking at this on the graph, I can see that I have a translation happening. I'm going to the left and I'm going down to go from the red vertex to the blue vertex. And so that matches up with what we know of the rules. With my rules, remember, if we're adding inside the parentheses, that's going to shift us left. So this is a shift left or a translation left. And then for my other one, I'm subtracting 5 outside the parentheses. That's why this has moved down. So this is a shift down or a translation down. So when I go to graph this, of course I could just look at this and kind of like pick some points and tap on it and see. It'll let you tap and highlight points and you can use those. Now that one's going to be difficult because that one's a decimal. Another cool thing with Desmos is if I select my function and then click this little gear sign, you see there's a little table icon. And so if I click the table icon, it will bring up a chart that you can use as a table for that one. And so on my table that it shows me right now, it says at -2 for my x, I've got -1 for my y. -1 is +4. And then we've got 0, 11. So it goes up too high that way. But the other cool thing is I can type in this one. All right, so let's say I wanted to go bigger than -2. Let's say I wanted to go to -3. Well, it says -3 is at -4. All right, and then I can change this to a -4, and that says when it's -4, we've got a -5. And then I can change that to a -5, and it says we're at -4. And now since this is symmetrical, all I got to do is just mirror my points that I got on the other side, because I'm starting to work my way back up. And so there we go. We have drawn our new function. Right? So that table is pretty cool. All right, let's try another one. Same instructions. Graph and describe the transformation of the quadratic parent function shown below. So this time they didn't use the f of x inside. It just has that squared. So it's just written in a different notation is all. I can still do like I did before. I'm going to go over here and I'm going to get rid of that. G of x equals. And then we've got -2 parentheses x minus 1 squared plus 3. So I typed it in just the way it looks on my screen. And so we can see there's a couple of things happening here. This has been flipped over. So definitely I want to say that there has been a reflection. And that reflection is from that negative sign. All right, so we've got a vertical reflection. It's flipped over the x-axis. All right, and then this also looks skinnier, right? If I started at my vertex for my blue, since this is flipped over, I got to go down. But if I go down 1 over 1, I'm out too wide, all right? So this has actually narrowed, and that's because we're multiplying by a number that is bigger than 1, right? So the negative and the 2 are treated as two separate transformations. So this is called a vertical stretch, and that's what caused it to narrow, all right? It's narrower, it's skinnier than the red function that we had, all right? And then looking at the vertex, I can see to go from the red to the blue, I have to move to the right and I have to move up. And that comes from what we've been adding and subtracting. So subtracting 1 inside the parentheses, that's what moved us to the right. And you can see we moved over to the right by 1. And then outside the parentheses, this plus 3, that's what caused us to move up. If we look at our picture, we had to go up by 3 to get to my new vertex. All right, and then so to graph this new one, right off the bat, I know my vertex is going to be at 1, 3, right? And then I can use my table on Desmos to help me find my other points. So I click on the gear, click on the table for that one, and it lists things out. -2, -15 is too big, but I can get -1, -5 on here. 0, 1, and then there's that 1, 3 for the vertex, and then we start working our way back down. So I'm just going to use that symmetry to get the points on the other side. All right, once you have your vertex, you can just start mirroring and see what you've got on each side. But that is it for this. So that's how we can identify our transformations.